In this lab, we'll be learning some concepts and practical skills for administering skinfold assessments. And we want to do this by the end of the lab to be able to understand why we do skinfolds. We want to be able to know what equipment is needed for skinfolds and to demonstrate proper techniques and procedures for administering and calculating skinfolds to predict one's body composition. The literature has reported there's a high correlation with subcutaneous skinfold thickness and overall body fat. In other words, the thicker the skinfolds, the more likely the greater amount of overall body fat one has. We can use skinfolds then to estimate body composition. And why would we want to estimate body composition? Because we know unfavorable body composition is linked to a myriad of comorbidities, including heart disease and diabetes. So we can ascertain one's risks for these. And knowing skinfolds and body composition is also important when we want to track a client's progress who's following an exercise prescription. We use this technique because with a trained technician who follows the standardized procedures and uses proper equations, the standard error for skinfolds is about the same as hydrostatic weighing. It has a standard error of about, I've seen in literature, about 3.5%. And it's a less expensive method and more portable than other methods. And there are many ways to estimate body composition, including dual energy X-ray absorbed geometry that uses low-dose X-ray. Its dosage is equivalent to about being outside in the sun for 20 minutes on a sunny day. We have air displacement plasmography, the BOD-POD, and it's similar to hydrostatic weighing in that it uses the Archimedes principle, but with air rather than water. There are lots of instruments that use low-emitted electrical current through the body, commonly called bioelectrical impedance analysis, or BIA. So we have things like commercial hand and foot scales. They're more affordable for the consumer, the common public, all the way to the in-body, which you'll see a lot in fitness centers and such, and to the quantum series, often seen in research laboratories and so forth. And some consider these more research grade, and they are obviously pricier. The class lecture goes over accuracy, advantages, disadvantages of these and others. In order to conduct skinfold measurements, you first need skinfold calipers. Calipers are made in different qualities. One of the most preferred when most precise measurements are needed are for example, Lang calipers. Plastic calipers are less expensive, but all calipers are made to be held in the right hand, and most have units of measure in millimeters. And finally, you'll need a flexible measuring tape to help locate them, mark the sites. It doesn't matter what kind of unit of measure this is. It doesn't even have to be a measuring tape. It can be a shoelace or a string you'll see in the tutorial. You'll also need a pen that can write on skin. And these are the standardized procedures for taking skinfolds. You're aware through lectures that there are many skinfold equations that can be used on. Depending what you use, you have to follow the standardized procedure that was developed for that equation. Now we'll be following Jackson and Pollock, but most of them are generally the same as follows. First, we always measure on the right side for the simple reason that's how the equations were developed, by the researchers taking measurements on the right side. Skinfolds should always be taken before any kind of exercise for two main reasons. One is to avoid any fluid shifts that can occur, and the other is to keep moisture from accumulating on the skin. So if there is moisture, some people can just sweat standing there, or somebody may have on excessive lotion, make sure you clean it off. This will help keep your pinch caliper from slipping. You'll soon see how to locate and mark the sites. We'll show you that later. And after the sites have been marked, measuring them. It's not recommended to measure the same site consecutively, but rather to rotate the sites. We'll talk more about that later. And finally, make sure the proper equations are used. Again, I'll talk more about that later. So we'll talk about locating some of the sites first. The chest is a diagonal fold, and it's halfway for men and a third of the way for women along the natural line of the skin between the anterior axillary line and the nipple. Think of the anterior axillary line as the front of the armpit. The abdomen is a vertical fold, which is about 2 centimeters, that's 1 inch, to the right and level of the umbilicus. Other equations were called for horizontal fold, but we're learning the vertical fold with this equation. The mid-axillary is also a vertical fold, and it's on the mid-axillary line at the level of the xiphoid process. The mid-axillary line, simply the armpit straight down through the hips, and the xiphoid process is found inferior to the pectoralis major. And this bony structure is often easy palpated by having the client suck in the abdomen or inhale deeply. The suprailiac is a diagonal fold along the anterior axillary line just above the natural angle of the iliac crest. The iliac crest is another landmark that can easily be felt, but if needed, you can ask the client to bend to the left to expose it. Now you'll see some equations that will use the biceps, but the Jackson and Pollock that we're using does not, so we won't cover that one. The triceps is a vertical fold at half the distance between the olecranon process, the posterior over the belly, the tricep. And this is a 2D image, but the tape or string would be flexed over the shoulder. I'll show you that as long as when you see the tutorial. The site often looks higher than midway after you mark it, often because we're used to seeing the tricep when the sleeve covers up the arm. But the measuring tape doesn't lie. By the way, this is the only time that the arm will be bent. When taking skin folds, the arm is hanging and relaxed. The subscapular is a diagonal fold 2 centimeters below the inferior angle of the scapula. This is easiest to find by having the client put the arm behind the back to push out the scapula. Again, when measuring skin folds in this site, the arm is hanging and relaxed. The thigh is a vertical fold, half the distance between the inguinal fold and the proximal patella at the midline of the thigh. To find the inguinal fold, have the client bend the leg. By placing the right heel and the left toes common, push your fingers into the thigh where it meets the pelvis, and then stretch the tape along the front of the thigh to the top of the kneecap. This measurement is often deceptive, kind of like the tricep, and it looks like it's higher than it should be since shorts often cover much of the thigh. But again, the tape measure doesn't lie. The leg should always be relaxed when measuring the skin fold, so when it comes time to measure the thigh, have the client rest the heel on the toe, just like what you see here, just like what you measure. They should not be standing on both legs. Also, be sure a table is nearby in case the client needs to hold on to it for balance. You'll also see some sites use the medial calf. Jackson and Pollock does not, but it's simply the vertical fold at the widest portion. And again, notice that the calf is not supporting any weight. Now, just a few notes on measuring with the caliper. The caliper will always be held in the right hand. They're only made for right-handed people. And the left hand is going to be used for the pinch. When you grab the pinch with your thumb and your index finger, jiggle the pinch and pull it in and out 2 or 3 times to make sure you have the subcutaneous fat and not muscle tissue. Remember, you're grabbing the skin fold just above the mark you made. Do not pinch the skin fold on the mark itself, because that's where the calipers have to go. Now that you have the skin fold pulled out, place the calipers under the pinch and on the mark for no more than 2 seconds. Any longer than this, and you could be compressing the tissue, thereby ultimately underestimating body fat. Take the reading to the nearest millimeter. One of the most common mistakes I see people make here is that they let go of the pinch with the left hand while they are measuring the caliper. Don't do this. Once you have the measurement, open the caliper and remove it. You don't want to drag the caliper off the skin fold. This can be uncomfortable for the client, so that's why we open it when we remove it. Now, instead of measuring the site consecutively 2 to 3 times in a row, it's recommended to move to the next site. Rotating sites ensures there are at least 15 seconds between each measure at the same site. You want to take a minimum of 2 measurements at each site. And if the 2 values are within 10%, which they say about 1 to 2 millimeters of each other, And you could take the average. Some scholars suggest to measure the site 3 times and to use the median. These are some equations to estimate body density. So the D with the subscript B there, that stands for body density, using skinfold thicknesses. Okay? It's important to know that these were developed because they are not interchangeable. They're not intended to be used across all populations. So it's important to know how these were developed. For example, the first one in the male section was developed using 18 to 61-year-old black men and male athletes. So it's not appropriate to use this on white males or elderly or children or women or obese individuals. The second one was developed using non-obese individuals, 18 to 61-year-old white males. And so in this case, it wouldn't be appropriate to use on other than non-white ethnicities. We'd want to do that. Same thing with the females. The first one was developed using 18 to 55-year-old black and Hispanic women, so we would not want to use that on white women. And the second one was developed using non-obese 18 to 55-year-old white women. So you get the picture. If you're assessing children of a certain ethnicity, you should find an equation that closely resembles that. You also see these equations do not directly result in giving us percent body fat, but rather they give us body density. Once we calculate body density, then we have to use another equation to calculate percent body fat. All of the formulas on this slide were developed by Jackson and Pollock in the 70s and 80s. Now, there are many other formulas out there for various populations. Some result in body density, some result in percent body fat. The key is to make sure you are using the correct one. Now, let's say I've collected all my Skinfold measures on 7 sites from my client, and I sum up the averages. I'll use this equation. Let's say my client was a middle-aged black male and some of his 7 sites was 113 millimeters. All you do is simply solve for the equation. Remember to do everything parentheses first, then exponents, multiplication and division, then addition and subtraction. You will notice that when calculating body density, we do not round. Carry out the decimal as far as you can. And now you're ready to calculate percent body fat from body density. To do this, we also want to use the proper equation. Again, there are many equations that will convert body density to percent body fat, just a few here. So make sure you pick the one that is appropriate for your client. In our case, we divide body density by 437 and then subtract 393 to get an estimated 19% body fat for our client. So there you have it. You now should have an understanding of why skinfold measures are conducted, the equipment that's needed, and you have an idea of the proper techniques and procedures for administering and calculating skinfold measurements to estimate or predict one's body composition. So now be sure to watch the tutorial next to see a demonstration of assessing skinfolds.